Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2021 Combined Science Physics Paper 2 Higher Tier. Question number 3 is on waves topic. A student made water waves in a ripple tank. Describe how the frequency and wavelength of the water waves in the ripple tank can be measured accurately. So they're asking about two different concepts here. Frequency, let me highlight the word frequency and wavelength. Now, there's different ways of measuring either the frequency or the wavelength. I'll discuss all of them here. So think of this as 2 marks for you to describe how to measure the frequency and 2 marks on how to describe measuring the wavelength. So in order to measure the wavelength, right, let me show you the answer, model answer here. Then we'll discuss it. In order to measure the wavelength, place a meter rule at the side of the screen perpendicular to the wave fronts. Right? Use the meter rule to measure the length of the screen. Take a photograph of the shadow on the screen. Then count the number of complete waves on the screen. And determine the wavelength by dividing the length of the screen. There's a word missing, of the screen, by the number of complete waves. By the length, actually, dividing the length by the number of complete waves. Or you could simply use a meter rule to measure the distance between two wavefronts, which tends to be less accurate. The first method is actually more accurate. So let me move this slightly this way, right? Let's say these lines that you're seeing over here is actually the wavefronts that you would normally see in the ripple tank. So if these are the wavefronts, you're going to put a ruler there and then measure the distance starting from that wave to this wavefront. So let's say that's 10 centimeters, and you may count the number of waves. So from there to there is 1, 2, 3, 4, 5, 6, 7 waves. So the total length of 7 waves is 10 centimeter. So in order to find how long one wave is, you would divide 10 centimeter by 7. That will give you the wavelength of average wavelength of one wave. The second method is simply saying measure the distance between two wavefronts. That is not going to be very accurate, but both methods are going to be acceptable here. So in order to measure the frequency, I can move this over that and get rid of this, I think. Oh, that's going to take some time. Let me get rid of all of this. Fine. In order to measure the frequency, again, there's two different ways. Right? The first method, count the number of waves that pass a given point. Time how long it takes for the waves to pass that point using a stop clock. Frequency is the number of waves divided by the time taken, which is the best method, I think. Right? Or you could put a stop clock on the screen, use a digital video camera to record the waves passing a point, replay in slow motion and count the number of waves passing a point in 1 second. Right? Again, counting the waves in 1 second is not going to be very accurate. This gives you an average value. So the ones in blue are the better methods. Next question. Right. So I have here the student recorded values for the frequency of the wavelength of waves in the ripple tank. So you have table 1 and table 2. They measured the frequency 3 times and the wavelength in centimeters. Now that's key. They have measured it in centimeters. Right? When you are doing any calculation, remember you have to have the wavelength in meters. Determine the mean wave speed. Now, the equation for wave speed is V equals F lambda. V is the wave speed, F is the frequency, and lambda is the wavelength. So in order to measure the mean wave speed, you need to find the mean frequency. So mean frequency is found by adding up the frequency values, which is 9.8, 9.4, and 9.3. So 9.8 plus 9.4 plus 9.3, and then dividing the total by the number of values, which is 3. This gives you an average of 9.5 hertz. And the mean wavelength I'm going to use the values in centimeters, and then we can convert the final mean wavelength to meters rather than converting all of these three values together. So 1.7 plus 2.2 plus 2.1, add all three of them up and divide it by 3, which is the number of values. That gives you, I think, 2 centimeters, which if you divide that by 100 will give you 0.02 meters. Now to find the wave speed, V is F lambda. So 9.5 times the wavelength is 0.02. That gives me 0.19 meters per second. So 0.19. Question 3.3. What is the advantage of taking repeat readings and then calculating a mean? So advantage of taking repeated readings and calculating a mean. There's a number of different reasons. The main two, right? It reduces the effect of random errors. Why isn't my pen working? There I go. Reduces the effect of random errors, right? Or anomalous readings can be discarded before calculating a mean. So let's say here you have 3 values in this table, and if one of them, this looks like it's actually way off, right? So you could actually discard this because these 2 values are actually much closer together, right? Question 3.4. The speed of the wave is affected by the depth of the water in the ripple tank. The deeper the water, the faster the wave. So in deeper water, the wave is faster, right? Now, explain how the depth of the water affects the wavelength, right? How does the depth affect the wavelength if the frequency is constant? Now, that's a clue here, right? If the frequency is constant, again, we need to look at this equation. V is F lambda. You're keeping that frequency constant. If you keep that constant, and they're saying the deeper the water, the faster the wave. If you increase the wave speed, the wavelength needs to increase as well if frequency is constant, right? So since the speed or velocity of the wave increases and the frequency is constant, since this velocity is increasing and the frequency is constant, the wavelength has to increase meaning the wavelength has to be longer in deeper water. That's the end of this question. I'll see you in the next video. Thank you.